All right, we are on to our next section, which deals with our kinetic and potential energy. So, I've already said that work and energy are related. Energy is defined as the ability to do work. You need to know that. Work is the process of changing energy level. But this next topic has to do with if it's determined on position or motion. Okay, so let's go to potential energy. This is the type that is associated with position. And we have different types of potential energy. In this particular class, we mostly just cover gravitational potential energy. There is an electricity chapter in this book, but we don't get there, unfortunately. It deals with electric potential energy. Also, there's a chapter that deals with waves, and that kind of goes along with springs, which is like elastic potential energy. So there's multiple kinds of potential energy, but we are going to focus mostly on just gravitational. So gravitational just depends on what height you're at, okay? So the equation for potential energy is given right here. It's mass times gravity times height. And it is measured in, it's still potential energy, so it's measured in joules, okay? So you'll have to know the mass, and the mass needs to be in kilograms, and you'll need to, of course, know that gravity is 9.8, and also whatever height that you're talking about, okay? And so the work can change the potential energy. As this book is falling through the air, its potential energy is constantly going to change. And then this word kinetic energy, we're going to get into more of it in a minute. It can change into potential energy. So I always think of like a roller coaster. Okay, so let's say that you're at the top of a hill on a roller coaster. And for this split moment right here, you're not moving. So if you're not moving, but you have height, then you have all the potential energy, okay? And as you start to go down the hill, you are losing potential energy because, I know that's not how the roller coaster looks when it goes down, but I just want to show you, like, see how that height has changed? And as you start to move, you start to increase your kinetic energy, right? And when you're at the bottom here, you have zero height, right? No height. But you're moving pretty stinking fast at the bottom of the hill, right? So you have all the kinetic energy. So here you have all potential energy. Here you have all kinetic energy, okay? This is like zero kinetic energy, and this is zero potential energy. And in the middle here, it's just sort of, it's changing, right, for both of them. All right. I was thinking there was probably an example. Yeah, there is. Okay, for potential energy, sorry. Okay, so let me see here. Let's go to my notes. And I gotta go to my next section. If I wait any time at all, it gets all crazy on me. All right, go to the next section. There we go. All right, so let's do example 3.5 really quick. So example 3.5, it says, what's the potential energy of a 2.14 kilogram book that is on a bookshelf 1 meter above the floor? All right, now it specifically said potential energy. It could interchange that with work, okay? So if it said work, remember work is force times distance, which is mass times gravity times distance. Potential energy's equation is mass times gravity times height. Do these two things have the same unit? They absolutely do. Okay, so it's the same thing. All right, so potential energy is mass times gravity times height, which is about 21 joules. Okay, so remember that energy is measured in joules, and remember significant figures. So we are good there. Because of this one and this one, we only want two significant figures. And let's see, example 3.6, this is how much work can a 5 kilogram mass do if it is 5 meters above the ground. All right, so I'm going to let you guys kind of mess with that for just a second. It's exactly the same type of problem that we just did, just different numbers. But this time it said work. So I just wanted you to know that you could use either equation and it works just the same. So I would pause it if you can, just to kind of try to work it out by yourself, and then unpause. Okay, so after you've paused, if you take 5 kilograms times 9.8 times 5, you should get 250 joules. Okay, so that's how you do potential energy. Now, this isn't given as an example on here in the book, but what if, like, for instance, it gave you the potential energy and it wanted you to find how high it was? So let me do one like that really quick. Let's say that it gave you that the potential energy was, I don't know, 15 joules, and you were talking about a book that was 2.5 kilograms, and it wanted to know how high that shelf was that it was on. So it wants to know that. How do you get the height by itself? Well, you gotta divide mass times gravity, right? Okay, so now this is where it's a good idea to know what a joule is. And we know that the mass is 2.5, and we know that gravity is 9.8. Okay, so a joule is a kilogram times meter squared per second squared. And the reason I wrote it out like that is so that we can easily cancel stuff out. Okay, so we've got, if you take, let's see, 15, I gotta do this in parentheses on the bottom, 15 divided by 2.5 times 9.8, I get 0.61. How many significant figures should I have? I should just have 2. 0.61 meters. So how did I get meters? Well, you cancel out your kilograms, your seconds cancel out. See how you have meters on the bottom and meters squared on the top? Well, one of those cancels that one. So you're left with meters. Anyway, that's not an example that's given here in the book, but it might be something that's asked either in homework or on a quiz or a test or something. So you might have to rearrange the equation a little bit. And it's not one that you can put in a triangle, unfortunately. So, you know, you just kind of you're going to have to do a little bit of algebra, not a lot. Not asking you to do the quadratic formula or anything like that, thankfully. Okay. I will touch a little bit on kinetic energy. Might have to make another. Well, I'm going to go ahead and stop this video.